Nitrogen fertilization. How to deal with nitrogen response curves. Nitrogen is the most important nutrient for plant growth and yield. However, excess nitrogen is costly and creates an environmental burden. This animation explains how to identify the optimum nitrogen application rate. Nitrogen response curves are a powerful tool to analyze nitrogen needs, optimize nitrogen application, and compare different fertilization options. Increasing nutrient availability increases plant growth and yield until it is limited by other factors. Optimizing nitrogen supply ensures that a farmer obtains the highest profits from his fields. Increasing nitrogen supply beyond the optimum, however, is detrimental to yield, quality, and the environment. The curve shown is known as the nitrogen response curve. Its shape depends on crop species, soil and weather conditions, water supply, availability of other nutrients, etc. Nitrogen supply is made of soil supply and fertilizer supply. Depending on soil fertility, some yield can be achieved without fertilizer application. Since soil nitrogen supply is variable, nitrogen response curves in general show the yield as a response to fertilizer application only. In order to determine accurate yield response curves, field trials need to be performed under scientific control. In this example, 5 different yield values have been recorded and the response curve has been fitted accordingly. Response curves are always based on data from the past. Nevertheless, they enable comparing nutrition options and forecasting results. One of the key findings of a nitrogen response curve is its summit. It corresponds to the maximum achievable yield. The corresponding nitrogen supply rate is also called the agronomic optimum. In reality, however, a farmer needs to maximize returns, not yield. This situation is described here. The yield is now indicated in euros per hectare. Likewise, the cost of fertilizer is indicated in euros per hectare. The more fertilizer is applied, the higher the cost. With increasing N application rates, farmers generate additional returns as long as the additional revenue grows faster than the cost of applied nitrogen. In other words, maximum returns are obtained when the slopes of the green and blue curves are the same. This is called the economic optimum. The economic optimum is always lower than the maximum yield. Environmental regulations might reduce application rates even further, preventing the economic optimum from being reached. Market prices of crops and fertilizers have an impact on the economic optimum. When fertilizer becomes more expensive, the slope of the blue line becomes steeper and the economic optimum shifts to the left. Vice versa, when the cost of fertilizer decreases, the economic optimum shifts to the right. When grain prices change, revenues are impacted, and the green curve moves up or down accordingly. Other factors, such as crop quality, may have an impact on revenues. For example, if a certain protein level needs to be achieved, increasing nitrogen supply might be beneficial. When comparing the impact of different parameters such as nitrogen form on yield and returns, we have to compare the corresponding response curves. Let's assume the dark green curve corresponds to ammonium nitrate, and the light green curve corresponds to urea. The same yield can be achieved with both fertilizers in this example. However, significantly more nitrogen is needed with urea than with ammonium nitrate. The difference is due to the higher nitrogen uptake efficiency of ammonium nitrate and the lower losses. Likewise, for a given amount of nitrogen, yield and revenues will be higher with ammonium nitrate than with urea. Optimizing the nitrogen rate is important not only to optimize profit, but also to ensure the least environmental impact. One important environmental aspect to be considered is leaching. Nitrogen leaching is independent from the nitrogen form applied. It occurs when residual nitrogen after harvest is washed below the root zone. During the growing season, crops take up water and nitrogen from the soil at high rates. Leaching is most likely to occur during heavy rainfall in autumn and winter. For nitrogen application rates below the maximum yield, the risk of leaching in winter is low, since the crop will have absorbed almost all of the available nitrogen in the soil. Response curves help to validate and calibrate precision farming tools so that the economic optimum can be reached under all circumstances. Crop nitrogen demand depends on the yield objective and is determined by weather conditions and crop health. Soil nitrogen supply depends on weather conditions, organic fertilizer application, and soil conditions. Fertilization needs to fill the gap between soil nitrogen supply and plant needs. In practice, fertilization is tailored to actual plant needs during the entire growth season by split application. Precision farming tools, such as the N-tester and the N-sensor, measure the actual nitrogen status of the crop. They enable precise prediction of the amount of nitrogen required to match the economic optimum. Precision farming techniques are most efficient with fertilizers that offer precise, predictable nitrogen release and fast uptake. Ammonium nitrate is therefore better suited than urea. In order to optimize nitrogen application, enhance uptake efficiency, and reduce environmental impact, quantify actual soil nutrient supply and fertilization needs by soil sampling. Monitor crop nitrogen status and use split application to meet nitrogen demand. Match nitrogen needs and application rates across the field by sensor-controlled spreading. Use nitrate-based fertilizer for predictable nitrogen release, even spreading, low volatilization, and fast uptake. Learn more about plant nutrition and fertilizers on our YouTube channel.